Okay, so moving on to part E. Now x1 plus x2 plus x3, there should be a note on your little paper if you're following along that says this is not the same as 3x. And we'll see that when we use the formula. Basically, with something like this, we have to treat it as 3 separate random variables as opposed to just 3 times x. And we'll see how that makes a difference. Okay, so if we find the expected value, or E, of x1 plus x2 plus x3, so we're treating it as 3 different random variables. Formula tells me I do e of x plus e of x plus e of x, exactly what you would expect. So 11 plus 11 plus 11, which is 33. But when we do standard deviation of x1 plus x2 plus x3, well, I can't just do as 3x and just multiply by 3. I have to do the formula. So I have to do this guy, and I would do standard deviation of x, or 9 squared, plus standard deviation of x, or 9 squared, plus 9 squared. Okay? So I'm using it as if it's 3 separate random variables, as opposed to just multiplying by 3. And it comes out different when we do that. We end up with square root of 243, which is about 15.6 as our answer. If we had done it just as 3 times x, we would have gotten 3 times 9, which is 27. So it's a completely different number. You may notice that our answer to part A and our answer to part E for expected value is actually the same, but our standard deviation is different. So this is not the same as 3x, and we need to understand that. Moving on to letter F. So this one is a little bit tricky. It says we're going to do 5x minus 3y. So expected value is always the easy one because it always does exactly what you think it would. So expected value for 5x minus 3y is just going to be 5 times e of x minus 3 times e of y. And that's all there is to it. So 5 times 11 minus 3 times 24, which is 55 minus 72 is negative 17. Standard deviation is a little bit trickier, and you may be able to look at this and immediately know exactly what you need to do. I always like to think of it as taking a step back and working through the variance. We said this on a few examples ago. The variance of x is going to be 9 squared, or 81. Variance of y is going to be 5 squared, or 25. So what I'm going to do is I'm going to take a step back and look at what if I found the variance of 5x minus 3y. So it's kind of combining our multiplying by a scalar rule with our adding to random variables rule. Okay, so what that would tell me to do is I'm going to do the scalar 5 squared times the variance of x plus 3 squared times the variance of y. Okay, it's a plus because remember, when you're adding or subtracting two random variables, variance always increases. So we're going to do that. So that would be 5 squared times 81 plus 3 squared times 25. And that ends up being a big number that I don't know off the top of my head. Do some quick. I think it's 2250, if I remember this right from class. Yep, 2250. Okay, so that's our variance, and then square root or standard deviation would just be the square root of 2250, which is 47.4. So that's one way to do it, is to work through the variance. Yes, it takes a little bit longer, but it's not quite as much to remember. Okay? So if you wanted to just work with the standard deviation formula, which is where we do the square root of standard deviation of x squared plus standard deviation of y squared, how that would change with these scalars is that I would do 5 times standard deviation of x squared plus 3 times the standard deviation of y squared. And that gets me that same square root of 2250, which is 47.4. Okay. So two different ways of looking at it. If you knew that that's what you needed to do with the formula, then that's fine. You don't have to go through the variance, but a lot of times that makes it a little bit simpler to work with. It's up to you. Just remember that we're always adding when we talk about standard deviation and variance, even if the problem is minus. So be careful with that. With expected value, it is a minus, but with variance and standard deviation, it goes to plus, and that is because variance always increases. So there you go.